Hello everyone, we are solving problems on the basic concept. In that, next question is determine the current through the 18 ohm resistor for the circuit shown in the below figure. This is the given circuit. So in the given question, what he is asking, the current flowing through the 18 ohm resistor, let it be Ix. Okay, if you observe here, this 5 ohms and 9 ohms are in series. So if two resistors are connected in series, what is the equivalent? Equivalent is summation of two resistors. So the equivalent for these two resistors is 9 plus 5, that equal to 14 ohms. Then circuit becomes like this. Okay, this is the Ix, unknown current. This 14 ohm resistor and this 14 ohm resistors are in parallel. If two equal resistors are connected in parallel, what is the equivalent? R by 2. So R by 2 means 14 by 2, 7 ohms. Or you can write R1 R2 by R1 plus R2. So 14 into 14 by 14 plus 14, you will get 7 ohms. So this is 7 ohms. Then circuit becomes like this. Now if you observe here, this 11 ohm resistor and 7 ohm resistor are connected in series. If two resistors are connected in series, what is the equivalent? Summation of two resistors. 11 plus 7, you will get 18. Again, this combination and this 18 ohm resistors are connected in parallel. So this is 18 ohms. So the equivalent is 18 ohms. So 18 ohms and 18 ohms are connected in parallel. So what is the equivalent? Two equal resistors are connected in parallel. What is the equivalent? R by 2. So R by 2 means 18 by 2. You will get 9 ohms. So circuit becomes like this. Again, this 13 ohm and 9 ohms are in series. So if two resistors are connected in series, the equivalent is summation of two resistors, that is 13 plus 9. Again you will get 22 ohms. Now this is 22 ohms. Equivalent is 22 ohms. Equivalent is 22 ohms, and this 22 ohms and this 22 ohms are in parallel. So if two equal resistors are connected in parallel, what is the equivalent? R equivalent is equal to 22 by 2, that is 11 ohms. So totally, what is R equivalent? R equivalent we got 11 ohms. Now what is the total current? This is total current. So total current IT is equal to total voltage by total resistance. So you will get 4 amperes. Now this is 4 amperes. If two resistors are connected in parallel, current is divided equally. Okay, if same value resistors are connected in parallel, current is divided equal. That is, this is 2 amps and this is 2 amps. This is 2 amps, this is 2 amps, because the equivalent is 22 amps and this is 22 amps. Both are in parallel, so current is equally divided. Now this is 2 amps, here it is 2 amps. Now coming to here, so this is 18 ohms. Again, this is 18 ohms and this is 18 ohms. This is 2 amps. If two resistors are connected in parallel with equal values, then current is divided equally. So what we are getting from this circuit, Ix is equal to 1 ohm. Or you can apply by current division rule. By current division rule, so this is current. So this is opposite resistance. Opposite resistance is 18 by, what is total resistance? 18 plus 18 into total current is 2 amps. So you will get 1 amp. So finally, what is Ix? This is Ix. Ix is equal to 1 amps. Next question is determine E0 in the following network. This is the given network. This network can be solved by using either nodal analysis or mesh analysis. If you want to solve by using mesh analysis, so this is one current, this is another current, and this is another current. This current is already given as 10 amps because this loop current indicates this branch current. This branch current is 10 amps. So this is 10 amps. So we need to apply loop equation. That means we need to write loop equation for this loop and this loop. Then solve these two equations. Then finally by Ohm's law, E0 is equal to 8 into I2. Or you can apply nodal analysis. So here this is E0. This is E0 because the voltage across 8 ohms means this is from here to here, from here to here, that is from here to reference node. So this is E0. Let it be node V1. So you need to apply. Here we have two nodes, so you need to write two equations. You need to write two nodal equations, then you have to solve these two equations, then you will get E naught directly. From mesh analysis, here one step is decreases. No need to calculate E naught by using Ohm's law because we get directly. Or you can apply source transformation for this one. Then you can solve this circuit easily. That means single equation is required for to find E naught. Okay, so by source transformation, so what is source transformation? This is current source parallel with 8 ohms. So what is voltage? V is equal to IR by Ohm's law. So I is 10 into 8 is equal to 8 volts. So what is the circuit? Circuit becomes like this. Okay, this is voltage source. So this source transformation can be written as voltage in series with voltage source in series with resistance. So voltage source in series with resistance. Resistance value is not changes, only changes voltage value. So here we got 80 volts. Now write the node equation for E naught. Okay, single equation is enough for to find E naught. So write node equation for E naught. So what we are getting? E naught from this. So if you want to write the node equation for E naught, assume this node has at highest potential. If it is highest potential, all currents must leave this node. So from this, what is this current? E naught minus 80. So this is plus, so E naught minus 80. These two are in series, so 8 plus 2. Next, for this branch, so current is leaving from here. So E naught, this is positive, so E naught minus 16 by 4 plus for this branch E naught by 8 is equal to 0. If you solve this, you can take common E naught. E naught, this is 10 plus from here 1 by 4, from here 1 by 8 is equal to 80 by 10 plus 16 by 4. If you solve this, you will get E naught is equal to 25.2631 volts. Next question is, find the C equivalent across the terminals AB for the network shown in the below figure. This is the given network. If you observe here, this is I1, this branch current is I1 means this is I1 and this is 49 I1. So what is current flowing through this capacitor? By KCL, two currents are coming towards to this node and one current is leaving this node. So this summation of these two currents is this current. So that is 49 I1 plus I1 is 50 I1. Now apply KVL for this loop. Let it be VR and let it be VC. From these, by Ohm's law, what is VR? VR is equal to 5 I1. And what is VC? VC is equal to 1 by C into integral of I of t dt. Now what is C? C here it is 200 farads. And what is current? Current is 50 I1. Okay, this is 50 I1 dt. Now by KVL. So what is the KVL? This is Vs is equal to VR plus Vc. Or you can write by KVL. So here current is leaving the positive terminal. So it is minus Vs. And here current is entering. So plus VR. And here also current is entering to the positive terminal. So it is plus Vc is equal to 0. From this equation you will get Vs is equal to VR plus Vc. Now what is Vs? Substitute VR value 5 I1 plus next what is Vc? So if you take V50 is common, you will get 1 by 4 I dt. If you observe here, this can be written as Vs is equal to, this is R equivalent into I1 plus 1 by C equivalent into I1 dt. Okay, so from this what is C equivalent? C equivalent is equal to 4 farad. Okay, in the next video we will discuss some more problems on this concept. Thank you for watching.